For section 4.1, we're in chapter 4 here, Introduction to Linear Equations. We're going to talk about the the intro stuff that has to do with graphing, the coordinate plane, the x and y, the ordered pairs, how to check your solutions, what an independent and dependent variable are. So we'll get into that. And got the definition there written, so you guys can pause and write that down, and the steps for determining whether an ordered pair is a solution, which is essentially just checking your answer. You're just checking to see if it's if both sides are true. If both sides are true, then you have a solution. If not, obviously it's not a solution. So for number 1, we're going to check a couple different ordered pairs there. We've got 2, -2, and we've got 1 and 5/4. So we're going to try that. So for A, we're going to put that into the equation. So we've got this equation, 3 times x plus 4 times y, and we want to see if that equals -2. So if we put those values in, we put in a 2 for the x and we put a -2 for the y, does it come out to -2? If so, then it's a viable solution. So like right here, that's 6. Right here, this is -8. And then this side equals -2. And right here, 6 plus -8 equals -2. So -2 does indeed equal -2. So that would be true. That does work. And then we're going to do the same thing for the other ordered pair. Put in 1 for x this time. And we're going to put in 5/4 for y. Now right here, that makes 3. Right here, these 4's cross cancel. And so you get 5. And 3 plus 5 is 8. 8 does not equal -2. So this would not be a viable solution. That would be a false. All right, for number 2, it says complete for the ordered pair 1 blank. So we have something missing here. Right here, we have something missing. So we do know the x. We do know that the x is 1. And knowing that, let's put in that value for the x. So we're going to do 4 times 1 minus 5. So you got 4 times 1. That's 4. 4 minus 5 is -1, not 1. 5 minus 4 is 1. Not the same as 4 minus 5, though. So there's your other value right there. The other value is -1. All right, now the steps for completing a table of values, you guys can jot this down as well. You've got to determine, when it comes to table of values, like when you have to put in an x and a y, you want to determine the independent variable, usually the x, and put in any value. The outcome will be the dependent variable. So a lot of times when you do this, you usually fill in one side of it. Like you'll fill in, okay, this is 0, 1, 2, and 3. And then based on those values, that's going to tell you what the y values are depending on the x values. All right? Or sometimes you'll have just the y values. You'll have like 3, -7, 0, 2. I'm not going in any specific order right there. And we have to go the other direction. So now the x's are the dependent values because they depend on the y. All right. And then other times, which you'll see, they'll be mixed up. You'll have like a 3 here, -2 here. We'll have a 0. We'll have like -5, something like that. Where it's sometimes the x is the independent variable, sometimes the y is the independent variable. But as long as we have 1, we can solve. We're just going to use inverse operations and solve all that. Okay, so for number 3, it says complete the table of values and then write the information as ordered pairs. So for number 3, we need to figure out these values. So we already have some x's predetermined for us. So we're going to put those values in. So we're going to do -1. -1 plus y equals 6. So when you do that, we're going to add 1 to both sides. Add 1, and you get y equals 7. So there's your dependent value. So 1, we put the 1 in. What did we get out? We got out a 7. Input, output is another way to put it. All right, so we've got 7. And we're just going to keep doing that. So we're going to do 2 plus y equals 6. So you're going to take away 2 from both sides. Take away 2 here and here. and you get y equals 4, right? So when x equals 2, y equals 4. When you put in -1, you're going to add 1 to both sides, and then we get y equals 7. And then I just noticed I made a mistake up here. I put in -1 for some reason. That should have been +1. Let me start that one over. Pardon me, I wrote the wrong number. So we're going to put in 1. It should be 1 plus y equals 6. Putting that 1 in there, and then we're going to take away 1 both sides. And the reason that one gave me pause is because I ended up getting 7, and I was like, wait, I got a 7 here. That shouldn't happen. If we end up getting the same y value for two different x values, that's not a function. That doesn't work right. So I need to put the right number in here. So that's a 5. This is a 7. We're going to keep going here. So we're going to put in -2 plus y, make that equal to 6. And this is a matter of adding 2 to both sides. And you got y equals 8. And that's it. All right. For number 4, it's kind of mixed up a little bit. So we're going to just fill in different parts here. So we're going to put in the x when we have the x. We're going to put in the y when we have the y. So we're going to do 5 times x minus y equals 9. And I'm going to put a 3 in. So that's our first value. And then just go through the motions of solving it. So you got 15 minus y equals 9. And then subtract 15 to both sides. Subtract 15 from both sides. And then when you rewrite it, be careful. Be careful. Now it's very tempting just to drop down a y, but notice there's a negative in front of it. So it's really going to be minus, another way to think of it is minus 1y equals -6. So now it's a matter of dividing by -1. Some of you have another strategy for doing this just by flipping signs. That's fine. But then you get y equals 6 right there. So there's your first y. Now the next one, we have the y value. So we're going to put all those values in. But this time we're going to replace the y. And we're going to put a -4 there. All right. Now notice there's a negative still there. So it's minus -4, which has a bearing on it, which makes it +4. So I'm going to rewrite it. I'm going to write 5x plus 4 equals 9. Subtract 4 from both sides. Subtract 4, and you get 5x equals 5. Divide by 5, and you get x equals 1. So that value, that 1 goes right there. All right, and we're going to keep going here. Now we're going to put 0 in for x. I'm going to do 5 times 0 minus the y equals 9. And 5, anything times 0 is 0. So now that cancels, and now you're left with -y equals 9, which is like the same thing as -1y. Divide both sides by -1, and you should get y is equal to -9. You got that, and we got one more to do, and we're going to put in -19 for the y, 5x. You notice, like, whenever, you don't have to do it this way, but notice, like, whenever I have a letter involved, I always kind of put parentheses in its place, and then I put in the number next, just to avoid any confusion. Because sometimes people put -19 down, but they count that as a negative. Well, that negative was already there, so you have to put minus -19, minus -9, which means plus 19 when you fix it up. So you got 5x plus 19 equals 9, and now just apply inverse operations. Start solving it. So now we got 5x equals -10. Divide by 5, and there you go. X equals -2. Now for number 5 right here, you'll notice the equation is very simple looking, but when it comes to graphing equations, so many people find this very confusing. So when it's a y-only equation, like y equals something, when it's y equals something, it's going to be a horizontal line. So it's going to be a horizontal line through the point given. So this one right here, it says y equals 9. So that is saying that every one of these values is 9. Every single one of these y values is 9. So this is 9, this is 9, this is 9, this is 9. That's it. For number 6, we've got -2, and so if we put in -2 for x, we don't have to do this every time and then solve it. Notice there's no y. Notice there's no y to solve. So what do we do with that? What do we do with that information? Well, the thing is that y could be absolutely any number. So y could be, this could be -3, this could be 2, this could be 0, this could be 153, could be anything. So it's all real numbers. As long as you put a real number in there, you're good. Now the Cartesian coordinate system for steps for plotting ordered pairs is, when you're doing this, it's always x. If you didn't already know this, it's always x and then y, right? Now your x is your horizontal position. That's your axis right there, your x-axis, horizontal. So there's 0, that's your origin. So we're talking about horizontal position, whereas the y, that's your vertical position, up and down, okay? So your y-axis goes up and down. So for this number 7 right here, we're going to plot the point 5, 1. So that means 5 on the x. So when we do that, 5 on the x, there's 5 right there. And then 1, up 1 on the y. So there's 0.51. That's 5 on the x, 5 on the x, and 1 on the y. And then for number 8, just go ahead and solve these, and just make sure I'll go ahead and do them too, but you can pause the video, just graph and make sure everything matches what I have. So hopefully your points kind of match there, what I have. All right, now moving on to number 9 here, we've got complete the table of values for the equation, then plot the points. So let's do that. So now we're kind of putting everything together at this point. We're gonna put those values in for x or y, depending on what's given. We got -1, -2 first, so I'm gonna go ahead and plot that. So -1, -2, -1 on the x, -2 on the y. Doing this, all right, so we got 0. So we do -3 times x plus y equals 1. Put a 0 in there. Now that 0 makes 0, which is now it's gone. So now you just got y equals 1. So that's our second point, 0, 1. So 0, 1 is going to be right there. And then for this last point, we're going to do -3 x plus whatever the y is, make that equal to 1. And I'm going to put in 7 for the x. I'm going to subtract 7 from both sides, rewrite it. So you got -3x is equal to -6, and then divide by -3. Divide by -3, and so now you get x equals 2. And so that gives us our third point. So 2, 7. Now the thing is that our graph the space that we're given isn't quite enough. So I'm going to add some, not very mathematical here, the way not being very neat either, but a general idea where it is. So we got 2, 7, and that's right where you would expect it to be, because it's following that progression. Because we're looking at this line, this linear equation. It's going in that progression, and that kind of follows that path right there. Never mind the fact that I kind of drew it not very straight, but it still works. Now for number 10, we've got the length of an 8-year-old female's hair is measured to be 250 millimeters long. So it's almost 10 inches. And that's the length right now. It hasn't grown any. So that's as of today. The length of her hair after X days can be approximated by that equation. So what we're going to do here for X, that's going to represent days. All right. The output is going to represent the hair length, the length of the hair. So that's what you should get. So we're going to put these are going to be our inputs. We're going to put those in. We got y equals, and I'm going to put 0.3 instead of 0.30. So 20 days here. Multiply that. That becomes 6 plus 250. That equals 256. We're going to do 256 millimeters there. And then for 30 days, we'll do the same thing. Put 30 in for x. We're going to still use that same equation, though. 0.3 times 30 is 9. So that you got 9 plus 250 equals 259. Then let's do 70 days. So we got y equals 0.3 times 70 plus 250, and then 0.3 times 70 is 21, plus 250 is 271. And now it's up to us to graph the ordered pairs. Now when it comes to the ordered pairs here, we only have a limited part of the graph that we can work with. So we're going to have to play around with the scale of our XY grid right here for our graph. So what I would do, if we look at our X values, it looks like, our highest number is 70. So I wouldn't go by ones. If we go by ones, this could be 1, 2, 3, 4. I mean, we'd have to make this really long. So that's not going to be very efficient. So let's go by tens. Let's go by tens for this one. So this will be 10. I'm just going to do every other. So that's 20. This is 40. This is 60. That's 80. And that's 100. I like to do that just because it gets too cluttered when you put in numbers everywhere. So you can kind of fill in the gaps there, because between 20 and 30, between 20 and 40 has to be 30. And then when it comes to the Y, we're going to put a little break in here. Put a little break, and our lowest number is 256, and our biggest number is 271. So we can just go by fives, really. We can go by fives here. And so we can put like 250 here. That's going to be 5, and then that's another 5. So this is going to be 260, and then this will be 270. This one right here will be 280, will be 290. Hopefully you get what I did there. And now we're ready to graph them. So 20 days. 20 days is it's going to be what? 20 days is 256. So that is going to be right about, and I'm just totally eyeballing it, about right there. And then 30 days is going to be 259. So that's going to be like right about there. And then 70 days will be 271. So 271 is about right there. And of course, it's not perfect because this is hand drawn. I'm not using a computer, obviously, to draw this. But you can see that that's linear. That's a linear progression right there. Although I don't think hair growth really is linear. I think it's somewhat parabolic, because as your hair gets longer, I think it grows a little bit less every day than it does when it's really short. I think something about the weight on the follicles, but never mind that. All right, so for C, we've got how long will it take her hair to reach a length of 262? So now that's basically starting with a Y. So we're going to do 0.3x, right? Because that's the equation. 0.3x plus 250 equals Y. So we're going to do 262 because we have the Y right here. So you have the Y, and then we're going to subtract 250 from both sides. Those go away, and now you got 0.3x. You got 0.3x equals 12, and then we're going to divide by 3/10. 0.3. Here's your x. So x equals 40. So it's going to be 40 days.